Hi, my name is Andreas. I'm co-founder of a company named Tottle, and we're building a brand new programming language. And I'd like to talk to you a little bit about Tottle today, what it is, and why we're building it. Before I start talking about Tottle, I want to touch a little bit on the history of programming. So this is going to be a very brief and mostly inaccurate summary, but highlighting some of the major events, right? So initially, programming happened exclusively in binary, right? When computers were invented, you fed them instruction sets and you basically fed them directly into the CPU for execution, right? And the first innovation that really happens with the idea of an assembly language, where you were still writing instructions directly for the CPU, but at least you had a little language to do it in. And usually that just meant that instead of typing in the binary instruction, you had a 3-letter name for it instead. And it wasn't until the 1960s we actually saw the first sort of real, what we today consider a programming language. So COBOL was the first language to have a compiler, and therefore the first language where you could start thinking about what makes sense from the view of the programmer, like what is a good experience from a programmer to write, rather than just what the computer wanted. And less than a year later, Lisp came out, which was both the first functional programming language, but also the first language that had garbage collection. And I realize I'm not entirely speaking to the choir here, but that was a big deal, right? So after that, just around 1970, Smalltalk came out, which is the first object-oriented program. So we now had multiple programming paradigms coming out in a relatively short period of time in the early days of programming, right? Also, ML came out, which was the first sort of functional programming language with a strong type system. And this whole idea of having a type system as a meta language for how you program was all invented in this period. And of course, C, which sort of became the grandfather of most languages that came after. And so after that, honestly, not that much happened in terms of the broad strokes. All the big major programming paradigms were invented in this sort of golden period from 1954-ish, or maybe early 1960 to 1970s, 80s. And since then, we haven't seen any major new paradigm came out. And we're just really spending our time arguing online whether procedural, functional, or object-oriented programming is the best paradigm for programming. And I think there's basically two reasons why that could be. One of them is it could be that we just figured it out and there's nothing more to come up with or invent. And the other one is maybe we just stopped asking the right questions. I want to add Rust in here because it does have an innovation, but I don't think it fundamentally changed how we think about programming. So it gets a small spot in 2015. I want to borrow a quote here from Grace Hopper, who built the first compiler for COBOL back in 1959. And she says, the most dangerous phrase in the language is, we've always done it this way. And when she said that, she was talking about the sort of more established computer programmers working in binary or assembly and simply not seeing any need for having a high-level, at least at the time, high-level programming language, because they already worked in binary or assembly and they didn't see any problems. And I think looking back at that seems ridiculous now, but I would argue that there's a good chance that we're actually in the same situation and that future generations will look back on us and say, well, why did they do it that way? And why did they do it for so long? I've spent most of my career building for the web and the web platform. I've built everything from back-end to front-end, and I really like working with UI and like working with user interaction. I think that's one of the most interesting parts. And therefore, the question that's been haunting me for quite some time now is, when did we decide that a text editor is the best tool for creating visual web applications? Because I think there's a lot of places where maybe the idea isn't so jarring of text necessarily being a bad medium for this, but if you're creating something visual, like a UI, textual representation just doesn't seem like the best option. And so what I'm basically suggesting is, if we look at how a programming language works, we generally have a source code. You will have a compiler that then first passes the source code into an AST, or an abstract syntax tree, and this is like an in-memory data representation of what that program is. And then it'll do some sort of optimization, checking all sorts of things, transformations on these transformations. Then it'll do some sort of checking, optimization, all sorts of transformation on this data model. And eventually it'll generate some machine code or maybe WebAssembly, very often end up being JavaScript in the end. And so all I'm suggesting here really is that what if we cut this bit off and then just replace it with a visual editor? And that editor will just work directly with the abstract syntax tree. So we're not really throwing away and reinventing the whole wheel. We're just saying, what if we take away the interface for our programming language and replace it with something else? And this is not an entirely new idea. Of course, the first example I know of is way back from that sort of beautiful productive period between the 60s and 70s. So this is Grail. This is a visual programming language built way before most computers had screens. And it ran on this RAND tablet, which cost $18,000 at the time. So I think never really made it to mainstream adoption for that reason. But you could draw up these nodes and these logic flows, and it could actually execute them. And this was, again, in 64, right? An example that I think a lot more people are familiar with is Visual Basic, developed in 1991 by Microsoft. And here we're seeing Bill Gates do a demo. And this actually almost made it mainstream. It got quite wide adoption, and quite a lot of people, credit this as their sort of entry into programming. But it was still mainly just the entry. So while Visual Basic isn't entirely dead, and actually there are still Visual Basic applications out there, it never really had that much impact on the mainstream programming community. And I think this is basically the story of all visual programming languages so far. Few like Scratch has made it into education, but generally none of them really managed to break into the mainstream programming community. I think there's basically three reasons for that. One of them is flexibility. A lot of these languages or programming environments were quite limiting in what you could do. And as a result, you might not be able to actually build the program you wanted to. You might sometimes realize that way too late. The other bit is collaboration, which is that they're mostly single player. So when we look at collaboration in code today, that is actually generally handled in the source code part, right? We check our source code into GitHub. We work with Git to collaborate. So collaboration is an element we need to fix because it doesn't really matter how effective a single person can be when you're almost always working as a team. And the last one is speed and performance. Historically, visual programming languages have just been orders of magnitude slower than other languages, and usually to a point where that just didn't really make them a viable option for most professional use cases. But if we're looking at these issues and holding them up against our model here, except for the collaboration part, none of them are really related to the idea that it's text. There's no reason why, if you cut the source code out, why would this binary over here be slower, right? And the same with flexibility. The flexibility of what you can express in a language isn't really defined. It can be limited by the syntax, but it's not defined by the syntax. So I don't think these things have to be limits. And that's what we took into the development of Tottle. So with that intro and that context, I'd like to actually show you Tottle and show you what we built. This is the Tottle editor. I've already pre-created product and pre-baked a little bit from home to save time. As I mentioned, my history is around building web applications. I personally think it's the greatest application platform we have. And as a result, Tottle is designed to build web apps. It's also specifically for building the front end. You can bring whatever backend, maybe you wrote one in Rust and wrote an API, a backend service in Rust, and you can use Tottle as a front end for that. So it's designed as a language or platform designed to fix a very specific problem. It's not a general purpose language. It's very much designed specifically for building web application front ends. And if you're familiar with popular Webflow builders, for example, Webflow, it probably looks fairly familiar. On the left, we have our element tree here showing all our HTML elements on the page. In the center, we have our canvas where our application is running. And on the right, we've got these tool panels where, for example, we can go and change the the color maybe of we can go change the color of like text, etc. We can go and edit all the styles of all the different things. We also can edit HTML attributes, and we can react to events as well. And so what I've pre-built here is just the HTML structure and a little bit of design for a news site, right? But there's no interaction. It doesn't do anything. There's no logic here, right? And so what I want to do is I want to add in a news API and fetch popular stories out, and then use that to render all the stories in my tottle application. And to help me with this, I've got this API, newsdata.io. And it's basically an API. You can sign up for it. There's a very generous free tier. And you can fetch popular headlines based on your query, and you can search by country, category, language, etc. Right? So I'm just going to copy the URL for this API here. And then I'm going to go back into Tottle. And here I'm going to go and create a new API. I'm going to call it news. And then in the URL, I'm just going to paste this right here. And so Tottle automatically passes that URL, and it'll then start fetching the data. And you can see we're getting back a list of results here, and we're getting the different titles and keywords, descriptions, and image URLs, right? So we're getting this list back, and Tottle passes this. And now that's available to our page. And so now what I want to do is I want to take this first article, and then I want to render that for every item in that result array coming back from our API. And so actually the first thing I'm going to do is I'm going to delete these other two, because they were just placeholders, right? So I'm going to take this, I'm going to right click and say repeat. And so what you're seeing here is what we call our formula editor. And this is part of the magic that makes Tottle work, right? What we've done is, instead of creating one editor for everything, we split it up into different editors, each addressing different part of the problem we're trying to solve, that problem being building a front-end application. So you already saw the visual editor here for designing and adding the content. And then here on the repeat, this is the formula editor. And here Tottle borrows a page from functional programming and separates pure functions. That means anything that's just computing a value, like a simple computation, and it separates that from things that has a side effect. And so formulas are all about computations, are all about pure values. In this case, because we already have access to the API, we just need to access the right data inside. So the formula we're going to construct here is going to take the API, and then we're going to drill down into data and then results. And this array right here is then the list of all the different articles coming back from my API, right? And so now we can see we've got one for every single article, we've got a new, or for every single article coming back from our API result, we've got an article here in our page. Now that we've done that, we can start wiring up the data here. So I'm going to take my H3 and click inside for the text. And up here, there's a little FX button. And this again opens the formula. So every time you see that, sort of say, okay, now you can use a formula for defining this. And now inside the formula, it's because I'm inside a repeat item, I've got access to the data we're repeating over. So I can just take that item and then the title. And now we can see every single one of them now have the right title. I can do the same for my description. And of course, the image itself, I can also go and take its source attribute and do the same thing. Item. And there we are, image URL, right? And now it actually renders the full list, right? And now when I go and either open test mode and actually scroll through here, or I can even go and preview the full page and it'll show this. Unfortunately, not all articles coming back from the news API actually has an image, but we can always fix that another time, right? Okay, so obviously this is a good start. Now we've got data on our page, but Tottle is not just about creating dynamic contentful pages. It really is about building interactive web applications. And we like to say the best way of thinking about it is if you can build it in React, you can build it in Tottle. And so we want to add a little bit of interaction to our page here. And so we've got this search field up in the top right corner. And I want to make sure that you can actually search, type into that and search through news articles. So the first thing I'm going to do is I'm going to create a new variable. I'm going to call it search. And we'll just say programming that'll be our default value for now, right? And what I can do on this input field is I can first take its value and say, I'm going to set you to be the value of the search variable. That means every time that variable changes, the value inside the input will automatically change. And the second thing I'll do is I'll go and add an input event so that listen for an input event. So when I input text into this field, I want to update the variable. And so we first talked about the formula editor, all about pure functions. What we're seeing right here is the workflow editor. And where formulas are all about pure functions and computations, workflows are all about doing things, right? So in this case, we'll add a new action, which is set search. So we're going to set a new variable for this value for the search variable. And we're going to here say the event target and then value, right? And again, this sort of flowchart actually style editor, you can do all sorts of complicated things in that. And we make that separation between what is an action, what is something that you do that affects the state of your application, and what is just a computation that's essentially just produces a value, right? And computations are side effect free, so you can run the same formula as many times as you want. You don't have to worry about anything else. And this sort of split from functional programming, again, really helps us keep things quite clean and easy to work with. Now that, if we go into test mode, I'll just press T, and now I can say AI, right? And if we go and inspect our variable now, search variable, it says AI and the current value here. The initial value here is what we set it when we first load the app, and this is the current value viewing, right? So now we have this variable that's already bound to that input field. And what I can do now is open my API. And down here in the query params, I can see I have this Q param that's hard-coded to programming. And you can see, once again, we got a little FX button. I can just go and I can tie this to search. And the second I do that, you can see we immediately goes and change this. Now it's hard to see this is anything to do with AI. But we can go and test it. Before I do, one little thing is I'm going to go and add a debounce of 300 milliseconds to the API. That just basically means if you start hammering this for change, which we're going to do as we start typing, you're going to debounce it by 300 milliseconds, right? So let's go and open this in a new tab. Right now we can see it's programming. We can change it to cars. And we can see it's got a little 300 millisecond debound, and then immediately go and fetch news about cars. We can news about Rust. Yeah, probably not, unfortunately, the language yet. There's still more PR work to be done. But as we're typing, we update that. And so this, you can see how we can use both our workflows and formulas and our UI together. Those are the three parts of the app to actually build these rather complex applications. Now, I want to show you some more examples of what you can build in Tottle. One of the ones is we have this quite stylish weather app that uses a popular, like a weather API to essentially fetch all this data and then render it in Tottle. It's a very simple example, but it shows you a lot of the things that are possible. A bit more complex example is this sort of beat that I built, which is based on a teenage engineering design. And we can punch in these beats. And we can also, like this maybe. Right. And we can turn up that up and down the tempo, etc. Right? You can try this out at tb.pro. If you want to give it a shot. And this is entirely built in Tottle using like the formulas, the actions, etc. for different event, and of course the UI is for building all the UI. So because obviously building applications is complicated, and just like if you're building React, you're not building everything from scratch. We have a large package system, just like you do with NPM or Cargo and Rust. We have our own package system where people can build packages and share them with the rest of the community. One of the packages here is a color picker. And so again, this is entirely built in Tottle, right? This is not like cheating and writing in code. This is built using the tottle editor and all these things. So it really is incredibly flexible and powerful what you can build. Another example of this is we have a Spring animation library here where you can do Spring animations. And we can change like the different properties of this. And these are packages that you can install in your tottle project and now start using them, so you don't have to start from scratch and rebuild everything. Right? So the last project I want to show you that's built in tottle is actually tottle itself. We built the whole editor, everything you've seen today. Everything I've demoed is itself an app built in tottle. And you can see right here, we've got a load up. So we can see our left panel component here matches what we've got out here. And so every part of this tool we built, we've actually built in itself. Like we can see an example from Formula. So the Formula editor I showed earlier, right? That is a tottle component built in tottle. So you really can build anything. Like when we mean if you can build it in React, like we built version 1 in React and then version 2 was built in Formula. So literally anything you can build as a front-end application, you can also build in tottle. I really think visual programming and visual programming languages is an area of research that hasn't quite gotten enough attention. The things you can do when you start working with specific tools for specific aspect of programming is really quite powerful. And it gives you some opportunities that you haven't before. Obviously, one of the big benefits is that it's much easier to learn for beginners. So bringing new people in to contribute to the project is a lot easier. But there's real power features for experienced users. And even though I've been coding for well over 20 years now, I still find myself working faster and more efficient in tottle than I ever could in a front-end language like React. So thank you very much for having me speak here. I appreciate it. I hope if you're curious, go and give it a try. Thank you very much for watching.